Hi, in this video we're going to collect like terms in order to simplify expressions. But here we've got a mixture of different variables together in the same term. And you might have like different powers. So like you've got mn cubed, the n is cubed here, whereas here we've got m cubed n, it's the m that's cubed here instead. Now let's see what we know about like terms. Like terms are just kind of like similar terms that we can collect together. So like terms. And what do we mean by like terms? Well, if you have the same variables and the same powers, then they are like terms. So for example, if I had, say, x squared, 3x squared, 5x squared, these are all like terms because they all involve the same variables. We only have x. And they involve the same power of those variables. So it's x squared, x squared, x squared. So these are like terms. And whenever you have like terms, you could collect them together to simplify it into one. What about another example? If we had, say, xy squared, we could also have 2xy squared, I don't know, 9xy squared. These are all like terms because they involve the same variables. They involve both x and y. And they involve the same powers of those variables. So here the x is not squared in all of these, whereas the y is squared in all of them. So they are like terms and they can be collected together. But if you had, say, x squared y, and you, for example, had 4x squared y, then these are like terms. But they're not like terms with these ones, because in this one, it's the y that's being squared, whereas in this term, it's the x that's being squared. So the power's on different variables here. So these are not like terms, and you wouldn't be able to collect them together. So let's apply it to these examples here. Remember, we underline each term, including the plus or the minus in front of it, if there's one there. So we've got the 5pq. Can we see another PQ term involving the same letters, the same variables, P and Q, without powers? Well, I can see that the minus 3PQ, remember you include the plus or the minus in front of it. And then these like terms here, we can collect them together. So if we have 5 lots of PQ and we subtract 3 lots of PQ, how many lots of PQ do we have? Well, we have 2 lots of PQ. So we have 2 lots of PQ in our answer. And then what other terms do we have? Well, we've got this plus 6p squared term. There's no other term which has only a p in it and it's squared. So that's just minding its own business. Doesn't collect with anything else, but we still got it. We've got the 6p squared there. And that is the final answer, right? So the next one, this first term here, let's underline it. Do we have another x squared y term? So the x has to be squared and the y is not squared. Well, yes, we do. We've got this x squared y term at the end. We've got minus x squared y. And remember, when we don't have a number, we can just put a cheeky 1. So it's minus 1 lot of x squared y. So let's collect them together. 4 lots of x squared y. Subtract 1 lots of x squared y. You have 3 lots of x squared y. So that's 3 lots of x squared y. And then what else do we have? We've got this xy term, the 3xy. There's nothing else that collects with that. It's the only term left. So we've got plus 3xy. And that is, again, the final answer. What about the next one? Well, we've got this first term here of 10. Remember, that's known as a constant term because it doesn't have a variable. It doesn't have a letter in it. Now, I don't see any other constant terms. There's no other term without any variables in it. So that 10 is just going to stay as 10. What else have we got? We've got this minus mn cubed. Is there another term where the m is not with a power, but the n is cubed? Yes, we do. You can see we've got this minus 3mn cubed. So let's put a 1 in front of this because it doesn't have a number. If there's no number, just put a 1. So we've got minus 1 lot of mn cubed, and we subtract another 3 lots of mn cubed. Well, negative 1 subtract 3 is negative 4. So we've got minus 4 lots of mn cubed. And then we've got this final term here, the plus m cubed n. Now, this is not a like term with that because here the m is cubed, whereas here and here the m is not cubed. So that's the only term, the only m cubed n term we've got. So we got plus m cubed n. And that is the final answer again.